Hello, dear learners. I welcome you once again in this exciting video. We'll be discussing ionic bonding. Is a topic, a very nice topic in chemistry. A lot of exam questions picked from this topic, the topic called bonding. So we'll be looking at ionic bonding, and the term bonding comes from the word bond. Okay, just the English word itself, bond. Okay, we usually use the word in our everyday lives when trying to express something. We say there's a bond between those two. Okay, so a bond is something that is felt by two things, okay, two or more things. Okay, so ionic bonding involves since we are looking at talking about atoms of different elements, so we'll be discussing this bonding that is taking place between atoms. Okay, bonding is simply taking place between atoms, could be of the same element or different elements. Okay, so that is what a bond actually is. And then there are two types of bonding, and the other one, which is called covalent bonding, which we're going to look at in our next video. We'll discuss covalent bonding, but in this video I just want us to focus on ionic bonding. Okay, so ionic bonding, sometimes it is known as electrovalent bonding. Okay, electrovalent bonding. This is due to the fact that this type of bonding involves the loss, okay, and gaining of electrons. Okay, so the loss and gaining of electrons is where the term electrovalent comes from. Okay, so electrovalency refers to the electrons being lost or gained. Okay, so in our previous video we discussed something. Okay, so let's look at an example just to build up on what we discussed last time. So if we have the element here, and this element is carbon, okay, that's the nucleus. So you notice that carbon, when you look at carbon, okay, carbon isn't a good example for covalent bonding. Let's talk about, let's say this element is sodium. Okay, let's look at sodium. We say this element is sodium. Sodium is called natrium in its scientific name, natrium. So natrium or sodium, it has a proton number of 11. Okay, it has a proton number of 11. So you have 11 here, and then the mass number is 23. So just to build up on what we discussed here, we said that when you come up with the electronic configuration, the first shell should have 2 electrons, and the balance here is 9. The second shell can have 8 electrons, then the balance will be 1. Okay, so you notice that this is what we call the electronic configuration. And please, if you're watching this for the first time, kindly watch the previous video on atomic structure where I explained how to come up with this electronic configuration. So the first shell, being this shell here, we are going to put two electrons in the shell. Then the second shell can occupy about a maximum of 8 electrons, and we show them in pairs like this. So that is 6, remaining 2 more which we are going to put here. Okay, so we have the 8 electrons, and the last shell basically must only have 1 electron. So this is how the electrons will be looking like in the element sodium. Okay, so now when you see this element here, there is what we call I don't know if we've heard of the octet rule. Okay, so these shells, they must occupy a maximum number of electrons. Okay, and for instance, the second shell, you can see that it is occupied to maximum of what, 8 electrons. Okay, it is occupied to maximum of what, of 8 electrons. And before I go into bonding, I want us to understand first, why are these atoms trying to bond? Why are they trying to bond with each other? Okay, so the reason is this: the fact that this element sodium has got an extra electron, just one, outside the shell, it makes this atom very unstable. Okay, this atom is actually unstable because of that one electron, okay, which is outside. So the stability of an atom depends on the electrons in the outermost shell. Okay, so you always pay just a close attention to the outer right, that outermost shell. So the outermost shell, which is this shell here, the last shell. Okay, so always pay attention to the last shell. How many electrons does it have? So the last shell should have a maximum of 8 electrons. Okay, the last shell must have a maximum of 8 electrons. That's according to the rules, okay, that governs the energy levels of these atoms. So the last shell should always have a maximum of 8 electrons. If it has 8 electrons, then that uh, atom is considered to be a stable atom. Okay, it's considered to be a stable atom. Not only that, but you notice the way we did. We said the first shell, second shell, third shell, fourth shell. So the first shell can occupy a maximum number of 2. The second shell can occupy a maximum number of 8. This one can occupy a maximum number of 18, and so on and so forth. The formula here we are using was 2n squared to find these. Okay, so if you use this formula here, replacing n for the number of shell. So for the first shell, n is simply 1. For the second shell, n is simply 2, and the third shell, n is simply what? 3. Okay, so that's how we were getting these. Okay, the octet rule formula. Okay, so now looking at this here, we can see that if the last shell has got 2 electrons, it is considered stable. If the last shell has got 8 electrons, considered stable. If it has 18 electrons, it will be considered stable. But most of the times, we find that the elements that we're dealing with, they don't go as far as having 8 electrons. Okay, so usually we just say that the last shell must occupy a maximum number of 8 electrons, right? Because of the type of elements that we deal with. Okay, so that's why I said it must occupy a maximum of 8 electrons. Okay, so now because of this instability, so just by looking at this atom here, it's very unstable. And the fact that sodium actually comes from a group 1 element. Okay, it's a very dangerous element. Okay, it's a metal in group 1. It is very dangerous, and because of this instability, it can easily react with anything around itself. Okay, it can react with anything around itself. For example, just by bringing in contact this sodium, you bring it in contact with water, you find that there could be a very vigorous reaction, okay, that can lead to a bit of an explosion. Okay, this is how these elements react. So when they're unstable, they can react with a lot of substances around itself. Just with water, you can notice the reaction is very vigorous. Now imagine if you reacted with an acid, that could cause it can cause serious problems. Okay, so we don't want these sodium elements to be unstable. For example, the salt that we take and consume in the food, you notice if you break down the elements found in salt, there is sodium. Okay, there is sodium, and there is sorry, I drew the whole thing. There is sodium, and also there is chlorine. Okay, so separately these guys are very dangerous. Okay, they are very dangerous, such that they can lead to serious problems in your body. But then, because they are combined, they bond together to form sodium chloride, which is the salt that we take in. They don't cause much harm to our body. So bonding actually helps. Okay, it reduces actually the instability of the atoms. Thereby, you find that the atoms are less reactive, because okay, they are not reactive at all because they have been bonded to something. So when sodium and chloride bond that's what we call the ionic bond. Okay, so these bond ionically, and this is the table salt that we usually add to our relish. Okay, now imagine if these two atoms were separate, and then you're even taking in water. This is very serious problem. Okay, so bonding actually prevents all these things. So this is the reason why atoms around us are always trying to achieve stability. Okay, they are always trying to achieve stability so that they are stable and they become a bit of unreactive with other elements. Okay, because when the sodium is reacted with this, it cannot it doesn't have this shell, okay, this electron which is outside, and we're going to explain how that happens. So now let's I think I've explained why these atoms are bonding. If you ask the question in the exam, why are these atoms bonding, why should atoms bond, you say this is to achieve stability. Okay, we have a group of elements in the periodic table, those that belong to group 8. Group 8 is also called group 0. It's discovered that all these elements, for example argon, neon, um, helium, all these elements which are found in group 8, they were all found, it was found that they have um, they have the maximum number of electrons. So this is their electronic configuration structure. All these elements in group 8, their last shell has 8 electrons, and because of this, these are known as noble stable gases. They are very stable. They are not reacting with anything because they are stable. So all the elements will try to achieve this stability that these group 8 elements have. Okay, so this sodium now, because of this, it makes it very unstable. So what is it going to do? So we're saying that ionic bonding involves the transfer of electrons from a metal to a what? To a non-metal. So we're saying a metal loses electrons while a non-metal gains electrons. So sodium being a metal, it needs to lose, okay? It needs to lose the electron. And which electron is it going to lose? The electron in the last shell. So now if it loses this electron, it's going to, the last shell will be the second shell, which is 8, and by this it has achieved stability. This is what actually happens. Okay, so this is what actually happens. So that's just introduction to ionic bonding. I hope it's been made clear. Okay, I hope it's been made clear why and how these atoms must achieve stability. Okay, so this can easily lose its electron there. Let's see how that can be done. So here we can see now that this electron was lost together with the shell, and sodium will look like this. Now this is not sodium, sodium is this, but this, what is this called now after it has lost this? So this is the sodium atom. Okay, this is the sodium atom, this is the sodium atom, the original sodium atom. This is the original sodium atom, and it has the electronic configuration 2 8 and then 1 because of this 1 electron. Now once the sodium loses this electron, it's no longer called, it is sodium, but then you notice there is a missing electron and a shell. So this one is not called sodium atom, it is then referred to as sodium ion. Okay, it is referred to as sodium ion with a plus there on top. So once a metal loses, we add a plus. Okay, it has gained a positive charge. You just, by simple explanation, when you lose negativity, you become more positive. That's why it will carry a positive charge. Okay, so it is losing negativity, so it's becoming more positive. So this is sodium ion with the electronic configuration of 2 8. Now the sodium ion here, this is stable, very very stable, very very stable. This is very unstable. So that we are saying a metal loses electrons while a non-metal gains the electrons. So in this case here, we are demonstrating that sodium atom has lost electrons. Okay, it has lost 1 electron. Okay, if it had 2 electrons, it would have lost those 2 electrons. Okay, so this is what we are trying to say. So ionic bonding, now once it is like this, now it shouldn't remain alone, it needs to undergo bonding. Okay, it needs now to go and undergo bonding. So it needs to find another atom that it can bond with. Okay, it needs to find another atom that it can bond with. Okay, so this is what will happen. So we've demonstrated this, the transfer of electrons. So now this electron that is lost, don't think like it will just stay. It needs to be transferred to what? To something. Okay, and it is transferred to a non-metal. it is transferred to a non-metal. So you notice that there's a transfer of electron here from the metal to a non-metal. So these metals that are being lost, they don't just get lost, but they are taken from the metal to the non-metal. Okay, and then bonding here will take place. So we're going to look at another thing. So just let's hold this thought here, and then we look at another element called chlorine. Okay, let's look at chlorine. So chlorine is a non-metal which appears in gaseous form. Chlorine appears in gaseous form. It is written like this, Cl. It has 17 there, and then 35.5. So the electronic configuration here, you have, this is the number of electrons, right? So in all atoms, the number that is down is the number of protons, but then you notice that for all atoms the proton number is equal to the electron number. Okay, is equal to the electron number. So these are also the number of electrons, right? So we can safely say it has 17 electrons. So we can draw this configuration structure. The first shell 2, the second shell 8. What is this? 10. Your remaining is 7. So the last shell is going to have 7 electrons, right? So it's going to have 3 shells. So shell number 1, number 2, and number 3. Okay, so let's now draw the structure for this thing. Okay, we can start with the last shell, which is the maximum. Okay, and then we can just do this. We do this, duplicate, and we do this. This will be our second shell, and we can just say duplicate. We make the last shell. Okay, so this is chlorine with 3 shells. So let's just show the, so now inside it now, this to carry the atom, you should just show the atom chlorine. So the first shell is having 2 electrons. You're going to show them like this, 2 electrons. We use stars now, using just dots or circles to show that. Then the second shell is going to have these electrons, always occurring in pairs. I'm just not using the stars. Okay, always occurring in pairs, 8 of them. And the last shell is going to have, that is 2, 4, 6. Then there's one extra one, 7 here. Okay, so this is chlorine. Now chlorine here, just like I explained on sodium, it is unstable. Why? Because of the 7. Okay, had this 7 been 8, it would have been very stable, but then it is so unstable. So what can chlorine do? It's not appropriate for chlorine to lose all these electrons, so it can just add 1. It can just gain, eh? So these guys, they just gain electrons. So it needs to gain an electron. And where this electron is going to come from, it will come from a metal. Remember what I said? I said that these electrons, they come from metals, a metal to a non-metal. So this is what is happening here. So this chlorine now, here's what is going to happen to the chlorine. Okay, so I have to do this. Okay, let me just do this. Sorry. Let me just duplicate this and take it here. Okay, so it has to gain 1 electron. The electron that is going to be gained will just come here. Okay, that electron will come here. Okay, making the electrons now here, it's now going to be 2, 8, 8. Count them, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 here. So it has moved from this configuration structure to this. and this one now it is stable. So this one, it is called chlorine atom, but once it gains this, it's now called chlorine, now chlorine ion, which is also called the chloride. So chlorine ion is called chloride. Okay, it's called chloride. All right, so okay, so it has gained the electron. So this electron now can come from this guy. It is lost all the way, it travels, and then it is gained by this. So it comes here. Now, since these two have, so there's a transfer, and I said it involves transfer. So the electron from the metal, this is a metal, and this is a non-metal. So once these transfer those electrons, now what will happen is that this and this now will react together. Okay, they've become ions. This one is an ion, this one is an ion. They are going to react together, and once they react together, it's very simple. You just put them together, like you just draw them together. Okay, so this bond that is taking place, the metal, we're following our notes, involves the transfer of electrons. So this electron that is lost here, we said this particular atom here was, electron was lost. So once it is lost, it went and added itself to the chlorine atom to stabilize it. So this is what you're going to see at the end of the day. So the ions now will come together because why? This sodium, remember we said the sodium now carries a positive charge, and the chloride will carry a negative charge. Now there is always an attraction between a negative and a positive, and once these two attract together, they now form sodium chloride. This is what we call sodium chloride, which is a table salt. So that's how table salt is formed. Okay, so I hope you've learned something here. And so a metal loses electrons. You've seen how metals can lose electrons, and then non-metals gain electrons. So you've seen how a non-metal gains the electron. So it gains one electron here. Okay, and then the two ions that are formed. So this is an ion, sodium ion, and this is an ion, chloride ion. They now just attract. Okay, they are going to attract to each other just like that. Okay, so I hope this is well explained. We can do another example just to make it more understood. Okay, so let's look at magnesium and oxygen. We see and try to understand what will happen. So you have magnesium and oxygen. So now let's see how the bond will take place. So the same thing applies, the transfer of electrons from the metal. So this guy is a metal, this one is a non-metal. So electrons must move from magnesium to oxygen. Now you don't know the number of electrons that are going to move. So magnesium, it is written as Mg, capital M with the G. It has the mass of 24. Let me write it from here. It has a mass of 24 and then 12. In oxygen, it is written capital O, the mass of 16 and 8. So this tells you it has 8 electrons. So magnesium has got 12 electrons. So let's do the configuration. 2 in the first shell, you remain with 10, and then 8 in the second shell. It can't go beyond 8, and then the last shell, 2 electrons. For oxygen, 2 electrons. 2 minus 8 minus 2, you have 6, so 6 electrons. So you notice these two, these are the electronic configuration. These are the electronic configuration. So you notice here that the last shell for these two atoms, they are very much unstable. This one, it has actually 2 electrons outside. 2 electrons in the outermost shell. This one has got 6, but we said the outermost shell should have how many electrons? 8 electrons. So these two are unstable. So what will happen? There will be a transfer of electrons. So this can transfer electrons to this. We know that what's a metal. So magnesium atom loses its 2 electrons. So these 2 electrons are lost, and then they are gained by oxygen. Okay. Then it becomes magnesium ion with a charge of 2. Then oxygen gains these two electrons and it becomes oxide ion with a negative charge of -2. So let's simply look at how these are going to look like. So let's draw this. Okay, you that are using freehand, me, I'm using digitalized stuff here, but you should try your best to just draw it nicely. Okay, so this is the outermost shell that I've just shown here. I'm going to show this. Okay, then I will do duplicate. This is the other one. I'm going to do this one so that it becomes my second shell. Okay, then I'm going to do duplicate again so that it becomes my last shell. So this is magnesium. We can show these electrons. So this is Mg, magnesium. Okay, that's 2 electrons in the first shell. Then that will be 8 electrons, 8 electrons, 8 electrons in the second shell, and then 2 electrons which are outside. You can draw them like this. So this is magnesium. Okay, now let us show oxygen. So just to make my work easy, I'm going to do this. I do duplicate. Okay, so since I'm making a video and I want to do, what am I going to do here? Okay, let's see if I can just erase. Okay, let's see now. I can just erase this part I make. Okay, do this part. Okay, no, let me just draw. Okay, so I'm going to draw for oxygen. Okay, first shell. That is too big. Okay, it's too wide. Yeah. So this is the first shell, and then I draw the second shell. Only 2 shells for this one. Alright, so this is oxygen. Or so the first shell will have 2 electrons, then the second shell has 6 electrons. Alright, so this is what we have now. So the magnesium will lose 2 electrons, so these 2 electrons will be lost. Okay, these 2 electrons will be lost, so we are just going to write it like this. This one will lose 2 electrons, and these 2 electrons, mind you, they need to be gained. Okay, so these 2 electrons, now this one has lost 2 electrons, this one and this one, so they will be gained. Okay, because this one has to gain 2 electrons. Why is it gaining 2? Because of the 6 here. We add 2 electrons, it becomes 8. So these electrons will be gained, and I'm going to use a different color here just to show that they are foreign electrons. Okay, so this is the transfer of electrons that is actually taking place. Okay, this is the transfer of electrons that is taking place here, and once this happens, you are going to have this. Now, since it has lost this electron, it's no longer going to have 3 shells. Okay, it's no longer going to have 3 shells. It's going to be something like this. Okay, it's no longer going to have 3 shells. Okay, just nope. Okay, just wanted to delete this one alone. Nope. Okay, so see again, using these digital things I'm failing to erase properly. Okay, but then it's making my work easy. Okay, yeah. So not to confuse anyone here, so why have I removed the last shell? Because it has lost the 2 electrons. It has lost the 2 electrons, but it's still magnesium. It is still magnesium. The 2 electrons, which are these, are still intact, and the 8 electrons, these ones, will still remain intact. Okay, they will still remain intact. So this is now called the ion. Once it has lost the electrons, it is now called ion, and it is written as magnesium plus 2. It has lost 2 electrons, so it gains a positive charge. And then now this one here, I'm going to select it. I do duplicate, and I do this. So this one now, it's oxygen, 2 electrons. Now it had initially 6 electrons. It had 6 electrons initially, but then it gains these 2 that have come from magnesium, and hence it is called oxygen -2. Okay. Sorry. So this is how you show these now. Okay, this is how you show. So this is the bond that has actually taken place, and then these two now, when they come together, it is now called magnesium oxide. Okay, that's how magnesium oxide is formed. I think by now you get the idea what is happening. So this is a bond, eh? So when I show this, just know this is a bond, and it's called magnesium oxide. I can't explain everything in one video, so just bear with me the little that I can do to simply try and make things easier. So this one now, the electronic configuration, it is now 2 to 8. This one also, the electronic configuration is now 2 to 8. So you can see that they're very much stable together. So that's just the introduction to ionic bonding. Okay, I don't want to make the videos too long, but I think it's for 30 minutes now. So we end the video here. Okay, and for those that need private online tuitions, you can just always contact me using this number. Okay, 6239. Okay, our country code is +26. You can reach me on WhatsApp. I'll be able to respond. Okay, so we end here.